let's get to Helm. I'm actually pretty surprised and also happy to see the poll results, because it seems that we have both Helm users, non-users, and also a lot of people that are thinking about Helm. I hope that every one of you finds something interesting in this presentation. So let me tell you what I have planned for us for today. We will start with the very beginning. So I will try to tell you a bit what is Helm, like in general, but also a little bit deeper, and why do we need it at all, or why you might need it, because maybe you actually don't. Then we will see how it works. So I will show you how you can use Helm to install apps, but also we will briefly discuss how the process of creating your apps looks like. Then we will jump for a second beyond the basics, and I will try to point you a few areas, few features where you need to pay attention, because there might be some surprises over there. And also we'll talk about one more topic that is very dear to me, which is using Helm at scale, which is a separate problem. And then I will try to summarize everything. Please excuse me if I have any issues with my voice today. I regained it only 2 days ago. I hope it will work for the whole webinar. But yeah, I just hope it will work, okay? So let's start with the basics. What is Helm? You can answer this question in many different ways, and there are different angles you can take at this question. The most general one is probably that Helm is a package manager for Kubernetes. So like there is a package manager for any other Linux distribution, or like there is a brew that you might be using. This is just a tool that you can use to install software on your Kubernetes cluster. But you can also take another angle and say that Kubernetes is a tool that allows you to group manifests. By manifest, yeah, I mean your typical Kubernetes manifests that describe your typical API objects, like deployments, like services, jobs, ingresses, and so on. Helm is also kind of a templating engine for your manifests. So for example, when you want to tune your manifests, make them parameterized, and allow for some conditional logic in your plain YAML manifests, you can also utilize Helm for that. Helm is also an application configuration tool, because when you apply a package, when you apply the application to a Kubernetes cluster, there is a dedicated mechanism that allows you to do last mile configuration of this package. And finally, this is our bread and butter at Giant Swarm, because I work for an area and for 2 teams at Giant Swarm that are responsible for providing managed apps. And as you will see towards the end of the presentation, we're doing all of that based on Helm. So the next important question, or maybe even the most important question, well, we know what it is, but the important thing is why I need it at all. So first problem, and the most important problem I think that Helm is trying to solve, is that Kubernetes has no concept of application, right? As I said, your manifests, your typical objects, typical API resources are things like network policy, deployment, ingress, service, and so on. But there's no concept of application. There's no way you can tell Kubernetes that my application, what I really want to run, is this service, those 2 deployments, and like 3 network policies, and this is my application. There's no way you can natively do this. Another problem that it tries to solve is assuming that we have a way to actually compose a set of YAML manifests into an application package. How can I distribute that? How can I make this application package distributable? So available to others, that's one problem, but also configurable to others. And Helm tries to solve both of those problems as well. So think about Helm as a tool that enhances Kubernetes with a concept of application, and that provides tools and means to build application packages and then distribute them over the internet. So there are like two sides of using Helm. First one is when you want to use Helm purely as a customer of packages. By customer of packages, I mean by someone who just wants to take a package and install this package. The other side of this coin is package developer. So someone who prepares the packages to be available, installable, configurable for you. Let me start with this end user perspective. So just someone who wants to get an application package and deploy to an existing Kubernetes cluster. So how it actually works. First of all, Helm groups together all the required manifest files in a single zipped archive. On the basic level, that's it. So you take a bunch of Kubernetes manifests, zip them together, that's it. But that's the simplest case. Actually, what Helm needs includes two things. The package that is called chart, and I will use this term now because that's what Helm uses. So that chart, that is your application package, might need an optional configuration from a user that is deploying the chart. In practice, in almost every cases, you need to tune something and you need to configure something. So what Helm does, it takes this application package, that chart, and the information that it gets from a user, combines them, and what it actually does is just prepares a set of Kubernetes manifests. So if you know the typical way of deploying resources to Kubernetes, like with kubectl apply and then your YAML manifest file, that's actually what Helm does as well underneath. Like it takes this application package, the chart, templates, because they are parameterized, templates with parameters provided from by the user. And as a result, it renders ready templates, applies this set of ready templates, templated YAMLs to the Kubernetes API, and additionally does some state management. So on the left side, you see that it saves your typical API objects, but it also saves some dedicated Helm-owned secrets that are used by Helm to manage state. I will show you this a little bit deeper in a minute, okay? What is important is that charts can be stored and shared online. I mentioned this already, but we store charts in sets that are called repos. And repos are actually just charts, so TGZ files, zipped files, that are available over the HTTP connection. So they are exposed by a plain HTTP server that additionally has one specific file that is called index.yaml that Helm can generate for you, which includes information about all the packages that are included in this specific registry. Now there's a new idea as well that is called Artifact Hub. I really recommend to go to the site artifacthub.io, which tries to be like a single point of entry, a gathering space where everyone can announce that they run a Helm repo, and you can look up what's in this Helm repo, and then you can use this repo to deploy your applications. This is pretty fresh, but already worth checking. Okay, so that's it. That's how it works from end user's perspective. Having said that, I'd like to show you also how it works, but not in theory, but in practice. Let's do something with Helm. So let me share my terminal. And let me show you a few basic Helm commands. Let's say I'd like to use Helm to deploy WordPress. Yes, the typical WordPress example. We start with checking what repositories do we have available. This is a list of repositories I have configured on my laptop. These are actually optional, let's say, or additional repositories that are driven by different organizations that allow me to install some additional charts that these projects provide. The stable repository is still available over here. It should be available by default. And what we can do with our repositories, we can obviously manage them, add, remove, and so on. But right now, we want to search in our repositories if there's a chart for WordPress. And come on, Helm, thank you. There is a stable WordPress chart. It is deprecated. Okay, let's ignore that. It's not an issue for us because we just want to install it for a very demo purposes, and we won't pay much attention if this chart is deprecated or not. So to install WordPress into my Kubernetes cluster right now, we can do Helm install. Now we need to give a name to the installation I'm performing. This is called a release in Helm. So I'm doing something like this. I take a chart that is named stable WordPress, and then I apply some configuration and make it a specific deployment with a specific configuration on my cluster. This is called a release, and Helm uses named releases. So I need to give a name here. And now it's enough to say what I want to install. Let me hit enter. This should fetch the chart, and I got a bunch of information, as you can see. This is useful if I really want to use this WordPress, but I don't. Let's just see what that did to my cluster. So let's start with asking what's on my cluster. Runs locally, it was completely empty. The default namespace was completely empty. As you can see, there are already some pods starting. So there are services, there is a deployment, there's a replica set, there's a stateful set for the database for MariaDB, and some pods are already starting up.
Łukasz, we lost the terminal view.
I have no idea why. Let me try to share once again. Is it working now?
Yes.
Okay, sorry, I have no idea why that happened. So once again, what I did, I'm not sure where you lost me, but we did just that. Helm repo list to list the repositories. I can see all the repositories over here. I did search for WordPress, which takes a bit of time, but let's do this again. Come on. Yep. And then what I did is just this command. Helm installed the name of release and the chart I want to install. And now we can already see that on my cluster, some pods are starting up, some objects were created in the Kubernetes API, and this is all done by Helm. So Helm took a chart, applied a default configuration because I haven't passed any, and then rendered a set of charts. And the result of rendering and applying those manifests, those YAML manifests, are the objects defined over here. Okay. What else can we see? Well, first of all, let's ask Helm, actually, what do you think about our cluster? And he says that right now we have just one release that is called My WordPress in the default namespace. In revision 1, we'll get back to it. It was updated for the last time. Here's the timestamp. The status is successfully deployed. The chart name was WordPress 903, and the version was 5.3.2. It seems we have deployed WordPress. That's pretty neat, but can we dig a little bit deeper and see what really Helm did over here? So, like I said, Helm saves its state, not its state, the state of a release on the cluster. And as you can see, when we released all the secrets over here, we have some account token that's expected. These tokens, these secrets are probably created by the Helm chart for WordPress itself. But we also have a secret that is of type Helm sh release. Let's see what this secret holds. So I'll run this command, so we will get the secret and output in YAML. And oh my, this is huge. So as you can see, Yeah, there's a lot of text and it totally looks base64 encoded. But the important thing is that we have all the metadata and you can find some familiar properties over here. The name of the release, the status, version, and you can see the timestamp and the update that we have performed by installing it, and so on. And additionally, in this secret, there's a full state, saved full state of the templates, rendered templates. So actually YAML files, API object files for Kubernetes, and any configuration we have passed, okay? If you really want to dig deeper, I'll show you how you can do this, but only briefly, and I will just copy the command. It's too long to type. So you can get the secret, and then you can, out of the secret, you can get only data release property. You need to double decode base64, and then it is still zipped to save some object space in the Kubernetes database in etcd. So you have to unzip it, and then you will get another YAML. And this YAML that you will get, let's have a look. It's exactly what was applied to our Kubernetes cluster. So here you can find a definition for pod. We can find some other things like, yes, another part of base64 encoded things. But over here, you can also see configuration for MariaDB. Let's find beginning of this chart, of this manifest. Oh, here it is. Here is a definition of a chart. So everything is possible to extract from this secret, right? And Helm uses this secret heavily to do next operations, other operations. So actually, what kind of operations? First of all, you can ask Helm about values that I have used to configure this deployment. So let me do Helm get values for my WordPress, for the release called my WordPress. This is null. I haven't provided any user-specific values. I used all the defaults. But Helm can already answer this question. It can answer it because all the values I have passed are saved in this secret. We can check something else. We can actually, let's save this name, and we can say Helm get manifest, and I will pass it through YQ for readability. And over here you can see, in a way easier way than we were trying to get from the secret directly, what was applied to your cluster. Stateful set over here for my MariaDB and so on. That's a lot of YAML or JSON depending on your formatting. But definitely easier way to do this. But you can do this because there's that secret where Helm keeps its state. What else we can do? The most important thing is that every chart, almost every chart, like, yes, it is in theory possible to not have any configuration options, but almost all the charts allow users to provide some configuration options. To learn them, you need to actually check with chart developer which options are available. For example, with the WordPress chart, there's an option that is called WordPress block name. By default, it is something like, I don't know, we'll figure it out, Helm block. No, not Helm block, something else, we'll figure it out. But I want to override this default value and make it Helm block. So what I'm trying to do now is I'm asking Helm, get this chart again and update a release that I have already created that is called my WordPress, but this time use configuration that is called, that sets a variable called WordPress block name to a value Helm block. Okay, let me hit enter. What it does a three-way merge between what is in the cluster, what Helm has saved in the state, and what I have entered over here as the configuration. Now, internally, Helm will figure out what has changed because you passed some new or different configuration options. It will then check which YAML files, which API objects definitions are affected by this change, and change only them live on your cluster. So we can already ask Helm how it worked. And Helm list now tells us that it is still deployed, but the revision now is 2. So we have changed something. My release was updated, and it's now running in revision 1, okay? If I want a little bit more visibility, I can ask Helm about history of this release. You can see that our first release that we did at this timestamp is now superseded. It was installation, and now the running, the deployed one, is an upgrade we did at this timestamp. When we have a look at pods that are running in our cluster, you can see an interesting thing. Basically, our WordPress installation is up for around 9 minutes, and you can see this over here with the MariaDB pod. But apparently, MariaDB pod wasn't affected by what I have configured here using the set option. So it wasn't restarted. The chart was rendered, but there were no changes detected for the MariaDB deployment. But Helm has detected that my reconfiguration of the release changed something over here. So the pods were restarted because the manifest, the API object, has changed as well. Okay. So let's now do one more thing. I have reconfigured, I have checked the history, a new version is running. What if I made a mistake? I didn't want to apply this change at all. It is wrong to name my block a Helm block. There is a nice option because there's a full history, and this history includes everything. Templates that were used and values that were used to configure those templates. I can always roll back. So let me roll back to my first release, okay? This is now, this should be now at this, running with the same state as it was just after we installed it. So with all the values set to default. Well, let's see, first of all, Helm list. It is now in revision 3 because we have affected our release again. It is deployed. Let's check pods. Okay, WordPress pod is restarting just right now. Let's ask about history. Our previous configuration attempt is now superseded because now we have deployed revision number 3, which actually is a rollback to revision number 1. So we have successfully recovered from a misconfiguration. Before I end this demo, let me just show you one more thing. What if you want to dig into a chart a bit, but without deploying it to your cluster? This is totally possible using a debug command that is called Helm template. What Helm template does is that it stops midway. So it takes your chart, it takes your parameters, combines them, renders the templates, and instead of applying them to a Kubernetes cluster, it just applies them to your standard output. So prints them on your screen. Simple as that. I can hit enter over here. And what I'm getting is a complete spec of all the Kubernetes objects. You can copy paste them. This is now plain old YAML with all the values filled in. And this is not applied to your cluster. It's just a text. You can analyze it, view it, whatever. We can try to do something like this. Let me show you. So by default, the name is users block. I told you I will figure it out later. But this is not applying any change to my cluster. On my cluster, it is running as it was when we did the rollback. But I can still check how using different configuration options will affect my rendered templates. And this is really powerful. Like you have an option, you are not sure what this option really means. What will happen when you configure this option to A or B? you can just ask Helm to render the template with this option being set, and then check what's in your templated output that is not applied to any cluster. This is pretty useful. One more thing, over here for readability, I'm using a very simple option and I'm setting just one. Normally, you will set probably multiple options, even for a single chart. You can as well provide them from a file. So you can save all your configuration options to a YAML file and then pass this file to Helm in this install or upgrade command.
Cool. Łukasz, we've got a couple of questions that might fit in. One is from Lacoste asking if you can share the commands you used. Is there like, a resource that you think, provides a list of overviews of very useful Helm?
I think there is. This is my next slide.
Ah, perfect.
So I did exactly that. Because yes, that was my expectation, that people will want to maybe run those commands after the webinar. So to make it easy to copy and paste them, here's the recap of comments I used in this demo. Okay, maybe not like 100% of them, but definitely all the important ones are over here. And yeah, here you are, just copy from the PDF after the presentation.
Cool. And another question was, if we roll back to version 3, what happens? Does it need to apply version 2, then roll back to 1?
The version 2 was the version that we had applied, right? So we had 1, then we reconfigured one option, this WordPress block name, and we went to version 2. And then from version 2, I said, oh no, that was a mistake. I want to get back to the state that I had in version 1. So I did rollback. And this applied the same configuration values that I had in version 1, but this resulted in version 3. So basically, yes, it is listed in the rollback as version 3. I was showing that. I'm running a little bit tight on time, so I don't want to get back to comments and sharing my screen again. But yes, in general, this is listed as version 3, but expectation is that version 3 is identical to version 1, okay, in the history listing. Okay,
cool.
Thanks. I hope this answers the questions. Yep. There will be more time also at the end of presentation, but if there is something burning right now, just interrupt me. I will try to answer during the presentation. Okay, so we have seen quite a good part how it is to use Helm as an end user that just uses a chart somebody else has prepared. Now, let's see how does it look like if you're a chart developer and you want to create a new chart and share with others. So basically, like I said, Helm chart is not much more than a bunch of YAML files that have Kubernetes templates definitions zipped together in a single archive, plus some extra functionality. So in general, the easiest way, if you're just starting with Helm and you want to check how to build your own chart, is actually to execute this command, Helm create my chart. Because, well, my chart is the name of your chart, so actually the command is Helm create. This is easy because this will create the whole directory structure that you need, some additional configuration files that you need for your chart, and also this actually creates a fully usable chart that deploys a demo Nginx server. So you can immediately see how it works. You can even deploy it to your cluster and it just works. But in general, you can also start from an empty directory because there are only a few steps involved. The first step is that you need to put all your manifests into the templates directory. So there needs to be a templates directory and you're putting your Kubernetes manifests over there. The next step is you need to decide what needs to be configurable. So you need to figure out which parts of your templates need to be actually templated. So values provided by user, where they need to be applied within your template. You put that into your templates, then you put values that you make available as configuration options for your users into the values YAML file. Last step is you need to describe your chart, provide some metadata into the chart.yaml file, okay? After that is it's as easy as Helm package name of your chart, and it will be created for you. So the archive, the TGZ file will be created for you. And if you can make it available over an HTTP with some additional single Helm command to generate the index file, this can be already installed by other people. I won't be doing this live because it will take a bit longer, but what I have over here on the slides is actually a working example. You should be able to copy paste it and it should work perfectly fine. So over here, I'm using the Helm create command to create the my chart. And as you can see, I'm listing what it has done over here on my laptop. It created a directory structure. Like I said, the important part is templates, where all the templates are included. And this includes a few of them. I will get back to this in a second. Then values file, values YAML, so what you make available for your users. And then chart YAML, which includes all the metadata, so a description of properties, name, author, things like that of your chart, okay? This example is a little bit more complex than a very bare bones minimum. So for example, as you can see in the templates directory, there is a tests directory. Tests directory includes YAML files, so again, Kubernetes manifests, but that will be applied as a testing stage of your deployment. So basically, this means after your chart is deployed to a cluster, someone installs this chart on a cluster, then this is deployed, whatever is in this tests directory. Usually, those manifests, they describe Kubernetes job objects. And these job objects, they need to successfully run to completion to mark the deployed release as successful. Okay, so you can do some testing over here. I will be skipping this for sake of simplicity. The same, I will skip charts directory. Charts directory can be used for managing subcharts or dependencies. I will get back to this for a second later, okay? But right now, to actually keep our example as simple as possible, I was doing a little bit of cleanup because I don't need anything that was created, all of those things that were created over here. So I don't need those charts. I don't need those tests. Also, the full deployment that was made available here in the templates directory. I don't need so many files to create a simple file, a simple chart. I can remove all of them because they are just Kubernetes manifests with two small exceptions. The notes.txt file is what was displayed at the end of my installation. Have you noted? Like at the end of installation, when I did Helm install, there was that wall of text basically that was describing, yeah, you can now use your WordPress, here's how you should log in, set your admin password, and so on. This was included in the notes, in the notes.txt file, right? This file is displayed to your user after an operation is performed, like upgrade on install of this chart. Next important thing is helpers TPL. Because this is all templated using Go language template engine, you can actually prepare some additional templates, some includes that you can then include repeatably, like blocks of YAML that you can reuse across your templates. And by default, Helm creates some really useful and very nice, typical, repeatable, reusable includes for you in this file. But we still don't need it. We could have removed it. Okay, so I left only one file, a file that describes my deployment. And this is also a very minimalistic version. This is like a normal Kubernetes deployment object described in a YAML file, but has some unusual additions. And they are always limited by double curly braces, okay? As you can see, there are a few places in the YAML where there are double curly braces. And let me go from the bottom, okay? The first one is in image pool policy. And over there we have double curly brace dot values. Dot values is a special variable in Helm templating engine, which just means I want to get a value that is supplied by a user. So what I was talking about before, that user usually supplies a chart with some additional configuration values, this is how I can reference them. So for example, if there is a value that can be set by a user that is called image.pullPolicy, here I'm getting a value of this user supplied configuration variable, okay? A little bit more complex usage is in a line one above this. So the line that sets the image, okay? Over here, I'm again doing double curly braces, get the value of image repository that the user set. But also later, I'm doing get a value of image tag, and then there's that pipe symbol. Pipe symbol, this is all related to Go templating. When you dig in, you will see this is all taken from Go templating engine. Pipe means I want to execute a function. In this specific case, I'm executing a function that sets a default. So this means if a user didn't set an image.tag value, I will use a default value, which is, and now there's another special variable called chart. .chart provides you with meta information about the chart itself. So chart up version is just what you as chart developer has said about the version of this chart. So you don't have to, like, if your chart version is 1.00, you don't have to type 1000 in like 100 different places because you need it there. You define this once in your chart properties file, and then you can use .chart.up version, okay? Now, going up, we see this typical selector and template part of Kubernetes templates, which is basically I'm doing a selector, and then my selector is basically the same as labels I apply to my pods, because I want my controller, in this case deployment, to just handle only those pods, and that's it. The most typical scenario, right? But this usually means that I have to type the same set of labels twice, one as selector and the other one as a set of labels applied. What I can do is I can define a template somewhere, like in this helpers TPL file that I mentioned on the previous slide, and then I can call include function. So I call the include function and I say, please include here a YAML snippet that has a name mychart.selectorLabels. And in that just includes spaces at the beginning of all the lines included, so it is intended correctly in the YAML structure, okay? So that's why this is 6 and this is 8, because there will be 6 spaces in front of those lines and 8 below, okay? This is really useful. That way I don't have to type the same set of labels and like annotations, things like that, over and over again. And the same goes over here for names and so on, okay? And this is actually fully workable example. Assuming the default generated helpers TPL, this will work. So now we need to provide, remember over here, we had .values, image pull policy, image repository, and image tag variables. We need to define those variables as options that a user can set. So we create a values.yaml file, or we edit it, and we provide an image object that has properties repository, pull policy, and tag. These are default values. By default, tag is empty. If a user or when a user deploys this chart, the user can still override using the set option with Helm install, Helm upgrade, and can override those values. Another missing part is just some metadata. So over here, we are just given a name, a description, and the version to our chart. And this is actually ready. We can call Helm package, and this will take my chart directory and zip it into a mychart 010 TGZ file, which you can see over here, and you can actually already install with Helm install and the file. Actually, for just local development and for local installation, you don't need to call Helm package every time. You can reference a directory directly. So just /mychart will work as well. TGZ is only necessary if you already want to make this chart available to others and be reachable over the internet. Okay, that covers the basics. If you're really starting to develop your charts, you will pretty fast need to go deeper. And some additional features that you can use include, remember about the Helm ignore file. Helm package is pretty stupid. It will pack everything that is in this directory into your TGZ archive. So if by any chance you have, I don't know, some extra files, binaries, whatever, lying around in this directory, remember to include them in the Helm ignore file. It works the same way as git ignore. Just ignore what you don't want in the packages. There are dependencies. So like I said, there is the subdirectory called charts. And this is a very simplified dependency management. It means that, for example, if I was creating this WordPress deployment, I can create a deployment for WordPress service itself, but I also need a database. If there is already a database chart that works for me and is good enough, I can include this database in my dependencies in the charts subdirectory. And this means that when someone deploys my chart, actually 2 charts will be deployed, one for the database and one for my WordPress service. But that's it, right? There is a dedicated support for CRDs. If you use a lot of like operators like we do at Giant Swarm, and you have a ton of custom resource definitions, you put them into CRDs directory, basically, because there is a problem with it. We'll get to that. There is no templating for CRDs, so you can't template CRDs. You just put ready definitions into CRDs directory, and they will be deployed and installed into your cluster before the application. So, for example, when your controller gets up, those CRDs will already exist. There are hooks, pre and post, and they can be run before or after commands like install, upgrade, delete, and rollback. Usually, they are Kubernetes jobs, and you need to remember that Helm doesn't manage them. So if they leave any resources behind, it's your job to clean them up. Helm won't do that. There are tests. I mentioned that already, that there was that tests folder. Again, these are usually jobs that you run after deploying a chart when the installation is done, and they need to pass to make it work. And everything that we've seen is actually based on Go template engine and the functions that it offers. So there's unfortunately another piece of documentation you need to reference, which is Go template syntax. This concludes the chart building part. Let me now quickly move to really some advanced topics. And first of all, let me mention quickly some limitations of Helm that can get sometimes really painful. I already mentioned CRD management. There's no templating, there's no upgrades. So even though there's that separate approach to files that are placed inside the CRDs directory, it is very limited. And actually, you might end up with just packing your CRDs into a separate dedicated chart and tell your users that, listen, you need to first deploy and install this CRDs chart, and only then you can deploy actual application chart. The problem is with cluster scope resources, because in general, Helm is namespaced. But if there are cluster-wide resources and you have a chart that delivers them, you install it once and it works. You install it for a second time, even in a different namespace. But these resources are cluster scoped. So basically, this results in a conflict. And now you have a big problem how to work around it, because Helm won't help you in any way. Hooks, like I said, there are hooks, but they are not owned by the release. So for example, where you remove or you upgrade or anything, you need to care about all the resources created by hooks manually. Go templating engine as such is one of issues as well in my opinion, because it has pretty poor readability, really complex syntax, and limited functionality. So it is not that good templating engine on its own. If you need to prepare a chart that will be used by multiple different Kubernetes versions, you will probably sooner or later hit a problem with changed API versions. You know, like they moved, for example, I don't know, Ingress from API group that was like beta, V1 beta Ingress into V1 Ingress. Now you need to provide a correct API version to a correct Kubernetes version. currently, this includes a ton of Go templating. So every API version, if you want to make it cross Kubernetes version compatible, you need to wrap up in an if statement in Go templates, and then figure out the correct API version, set the API version, and the if statement. There's no help from Helm at all. Like, this seems like very easy problem to solve, very simple to just check on which target cluster version I'm deploying my chart and set the object versions correctly. But this also changes the object structure, so maybe not that easy. After all, right now you need to do fully manually, and it hurts. And the second, the last problem I wanted to mention is that it has no real composability. So every Helm chart is starting from scratch. It's very hard to make something that is repeatable across Helm charts. And also this dependency management that I already mentioned, it's just, here's my chart, and I want this chart to include another chart as a whole. There's nothing else I can do. That's the whole composability there is in Helm. Now, except of those problems, I want to also point out a few high-level problems, operational problems, and challenges that you may have when you will start to live by Helm charts. First of all is, how do you do quality assurance for charts? How do you test charts? And how you deliver the same chart for a fleet of clusters, not a single cluster, but multiple clusters, yet you want to have some configuration options. One area that is worth checking if you have those problems are GitOps-based tools or GitOps CD tools that have support for Helm. Over here, I can recommend two open source projects that are Flux and Argo. And over here, you have links. If you're interested in this topic, that's the place where you should start. But also, like I mentioned, in Giant Swarm, we live by Helm, and we serve all our customers, and we deploy all our apps across all the clusters using Helm. But to do that, we need to enhance Helm with a few tools. So we have a tool that is dedicated to building charts in a more opinionated, testable way, then a dedicated way to test Helm charts running, like runtime tests, and then tools that we use to deliver Helm charts at scale and make them more configurable. Let me start with the chart building and testing part that we use and we developed at Giant Swarm. This is all open source software, so you are free and welcome to use it, enhance it, comment on it, and so on. Yes, it is still in development. Maybe the documentation is missing somewhere, maybe not. There is some documentation, it's not like there's none. And we are using this daily as our daily driver here at Giant Swarm. So first thing, we have a tool that we called App Build Suite that is basically like Helm package on steroids. So yes, it is exactly running Helm package underneath, but other than that, it runs a few quality assurance tools. These tools include chart testing, kubelinter, so we know that our charts are well formed, that there are no typical mistakes that you can make when you develop a chart. Okay, so makes our life easier and makes the build process repeatable and allows us to easily check for some quality issues. Then we have another tool that is called App Test Suite that we use for testing charts live. By live, I mean, yes, my chart may be very linted and there might be no like syntax problems and so on, but still, does it run? Does the application defined in this chart even start? So we do that. What we do is that we deploy this chart to a cluster, and then we run a set of tests. To make it easier, we have also provided a tool. You're welcome to check it. And the last problem that we have is delivering charts at scale. And to do that, we have developed a set of Kubernetes operators that allow you to manage charts across a fleet of clusters. The most important thing is that we provide, in this solution, we provide a single control plane, a single control point that you can use to develop to deliver your cluster, your charts across multiple clusters. So there's one dedicated operations cluster that has connectivity to all the other clusters that we want to manage, but you as an operator, you interact only with this control point, with this management cluster. From there, you can deliver, you can deploy any Helm chart to any cluster with additional benefit of multi-layered configuration. So our configuration can be split into multiple layers, which includes like an application default, installation default, and then still you can tune this like last mile tuning of configuration if you need some per cluster different options, and usually you do. So that way we have split what is a single configuration file in Helm into something opinionated but very flexible, where you can override your config options at different configuration layers. Okay, this includes like over here you have a list of operators that we have created, and again, you're really welcome to go there and check if maybe they will solve a problem for you as well. So we're running out of time, but I have finally arrived at the summary. Helm is the de facto standard in Kubernetes ecosystem. There are many charts available online. Really, if you're looking for a Kubernetes ecosystem app, 99% there's already a Helm chart for it. But also, you need to be aware that running Helm introduces some problems. What we like about Helm is that it is pretty easy to use. So if you have a single cluster and you just operate that, getting started and deploying a few apps is really easy. Also, the deployment model that separates chart config values and combines them into releases, this is really useful and turned out to be very, very elastic for us as well. What we don't like is those pain points that I mentioned. And, well, you need some additional tools to make Helm really usable for a fleet environment. Because otherwise, well, managing one by one a set of clusters, that's not really manageable, that's not really doable.